Hello, hello. Here is the video going over our Chapter 4 Graphing Trig Functions test review. The first topic is going to cover the unit circle. So number 1 says to fill in the radian measure and the coordinates of the unit circle. So I have the unit circle on a different slide, so I have more space to write on it. And filling in the unit circle is not that bad as long as you remember some patterns. So I'm going to go ahead and start with my angle measures first. I like to start with pi over 4. So pi over 4 is the angle that's right in the middle of your quadrant. The equivalent to pi over 4 is 45 degrees. So it ends up being right in the middle of your quadrant because a quadrant is 90 degrees. And if I cut that in half, which is 45 degrees, that's your pi over 4. So every increment of 45 degrees is going to be an increment of pi over 4. So I'm going to go ahead and start counting around the unit circle. So I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and finally 8 pi over 4. Now, if you'll notice, some of those fractions can be reduced. So after I've gone through all of my counting, I'm going to go ahead and reduce my fractions. But before I reduce them, I'm going to go ahead and find my other angles by doing increments of pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then finally 12 pi over 6. So you'll notice that some of those angles have two angle measurements on them, and that's because whenever you're counting around the unit circle, you're always going to include the y-axis and the x-axis as you are counting. So now that I've completed all of my angles, I'm going to go ahead and reduce all the angles that can be reduced. So for example, 2 pi over 6, that reduces to pi over 3. So I'm going to go ahead and erase this and write pi over 3. 2 pi over 4 and 3 pi over 6, both of those reduce to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 6 pi over 6 and 4 pi over 4 both reduce to just pi. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 and 6 pi over 4 both reduce to 3 pi over 2. And finally, 10 pi over 6, actually it's not finally because I do have some other ones I still need to reduce. 10 pi over 6 reduces to 5 pi over 3. And finally, 8 pi over 4 and 12 pi over 6 both reduce to 2 pi. And I also forgot to make a note that 2 pi is also the same thing as 0. And now you have all of your angle measurements in your radians. From here, you're going to do your ordered pairs. So for my ordered pairs, I always like to start with the ones on my x-axis and my y-axis because those are the easiest. It is called a unit circle because your radius is 1 unit. So when I am filling in these coordinates, it's combinations of zeros and ones, since your unit circle has a radius of 1 unit. So this becomes -1, 0, and down here I have 0, -1. For the other ones, I'm going to go ahead and do the first quadrant. So when I look at pi over 6, this point right here, it's pretty close to 1 when I'm looking at my horizontal distance. When I go straight down, it's pretty close to 1. So when I think back at my angle measurements, not my angle measurements, my ordered pairs as numerical values, like on a number line, we have 3 numbers that you'll usually use. Root 2 over 2, root 3 over 2, and 1/2. Root 2 over 2 is approximately 0.707. Root 3 over 2 is 0.866 approximately, and of course 1/2 is 0.5. So when I look at this first angle measurement of pi over 6, that x-coordinate's pretty close to 1, so that means my x-coordinate's going to be root 3 over 2. And where root 3 over 2 is, there's always a 1/2. They're best friends. So they're always together with our coordinates. For pi over 4, that is going to be root 2 over 2 and root 2 over 2. And for pi over 3, if I go straight down, that's at 1/2. So my x-coordinate is 1/2. And of course, where there's a 1/2, there's a root 3 over 2. And now that I have my coordinates in the first quadrant, I can literally just reflect them, and they're going to travel around the unit circle. So if I go straight across, this is also 1/2 and root 3 over 2. But of course, since I'm in a different quadrant, my x-coordinate is negative. If I go straight across from my pi over 4, that's root 2 over 2, root 2 over 2, but my x-coordinate's negative. Then over here, I have root 3 over 2 and 1/2, x-coordinate's negative. And as I keep traveling around, I just got to change my signs. So this down here is root 3 over 2, 1/2, both negative since I'm in the third quadrant. Root 2 over 2, root 2 over 2, both negative, 1/2. Root 3 over 2, both negative. And as you can see, it gets quite repetitive because these are just following patterns. And so when you're doing that unit circle, it's really not that bad as long as you remember your patterns. Now that I'm in the fourth quadrant, my x is positive, y is negative. So again, I just have these same coordinates around my unit circle, but just with different signs because I'm in different quadrants. This one's root 3 over 2 and negative 1/2. And voila, you have your entire unit circle filled in. Now that you have your unit circle filled in, you can go ahead and use these values to answer the other questions. So I'm going to go back to my previous slide. Number 2 asks, what quadrant is each of the following radian measures? 7 pi over 3. If I go back to my unit circle, I do not see a 7 pi over 3 on the unit circle. So what that means is I need to either add 2 pi or subtract 2 pi. Since it's bigger than what's on the unit circle, I'm going to go ahead and subtract 2 pi. Keep in mind when you're subtracting fractions, you need that common denominator, so that's 2 pi over 1. So really what I'm subtracting is 2 pi in terms of thirds, which is 6 pi over 3. So that gives me pi over 3 for the angle equivalent on that unit circle, and pi over 3 is in quadrant 1. And go back to my unit circle. I can see pi over 3 is right here, and that is in the first quadrant. All right, negative 5 pi over 6, that is a negative angle, so instead of subtracting 2 pi, I'm going to add 2 pi. But of course, we do need that common denominator, so I have negative 5 over 6, so this is in sixths. So 2 pi in sixths is 12 pi over 6. So really, the angle I'm looking at is 7 pi over 6. I'm going to go to my unit circle. I'm going to search for 7 pi over 6. Oh, here it is. It's in the third quadrant. Now, if you add or subtract 2 pi and you're still not at an angle that is on the unit circle, that just means you need to add or subtract again. So sometimes you may need to add 2 pi again or subtract 2 pi again until you get to an angle that is on the unit circle. All right, number 3, convert the following angle measures to degrees or radians. For letter A, I am starting with radians, so I want to convert to degrees. What you need to remember is that pi in radians is equivalent to 180 degrees. So I can replace this pi with 180 degrees. I'm going to take 9 times 180 and divide that by 11, and that gives me approximately 147.3 degrees. Similarly, when I'm converting from degrees to radians, degrees is going to stay on top. I'm going to divide by 180 degrees, and I'm going to multiply by pi. So essentially, I'm multiplying by pi over 180. So that fraction can be reduced. That's 31/18. So that's going to be 31 pi over 18 for that radian measure. All right, next up, finding the exact value of trig expression, simplify completely. So when you're finding exact values on you have to use that unit circle to find one of your coordinates. So what you need to remember is that your coordinates, so x, y, that coincides to cosine for your x, sine for your y. And a tangent is our oddball because tangent is going to be a ratio of sine and cosine. So tangent is y divided by x. So you'll use both of those coordinates. So I have sine of negative pi over 6. So what I want to do is I want to add 2 pi because negative angles are not on my unit circle. So what I'm really looking at is I am looking at sine of 11 pi over 6. Because again, when I add 2 pi, I need to have that common denominator. So I'm really adding 12 pi over 6. So I'm at 11 pi over 6. So I'm going to go back to my unit circle. I'm going to look at 11 pi over 6. Here is 11 pi over 6 with my coordinates. And my question asked for sine. Sine is my y coordinate. My y coordinate is negative 1/2. So my answer for this one is negative 1/2. Cosine of 17 pi over 6. So again, I need to adjust my angle. So I'm going to subtract 2 pi, but this is in sixths. So what I'm really subtracting is 12 pi over 6. And that leaves me with the angle of 5 pi over 6. So I'm going to go back to my unit circle and I'm searching for 5 pi over 6. 5 pi over 6 is over here. And this question was asking for cosine. Cosine is my x coordinate. So my x coordinate is negative root 3 over 2. So my answer for this one is negative root 3 over 2. Tangent, like I said, is our oddball. So tangent uses both our x and our y coordinate. So I'm going to go ahead and start by finding 5 pi over 3. 5 pi over 3 is over here. X is 1/2, y is negative root 3 over 2. So I'm going to go ahead and write it down. So x was 1/2, y was negative root 3 over 2. So tangent's y over x. So essentially I'm taking my y coordinate, dividing by my x coordinate. Now when you're dividing fractions, what we really want to do is change it to a multiplication problem. And when I change it to a multiplication problem, I'm going to multiply by the reciprocal, meaning I'm going to take my second fraction and flip that sucker over. So that becomes 2 over 1. My 2's are going to cancel because I have same thing on top, same thing on the bottom. So that leaves me with negative square root of 3 as my final answer. Now, for these other ones, secant, cotangent, and cosecant, you do need to remember these are reciprocal functions. You need to remember what they are reciprocals of. So secant is the reciprocal of cosine. So what I really want to do first is I actually want to find cosine of 7 pi over 4. So I'm going to go back to my unit circle. I'm going to search for 7 pi over 4, which is over here. And cosine is my x coordinate. So my x coordinate at 7 pi over 4 is root 2 over 2. So I'm going to go ahead and make a note that cosine of 7 pi over 4 is root 2 over 2. Now, that is not my final answer because I am actually trying to find secant. So what I want to do is I want to take this fraction and flip it over because reciprocal functions are just reciprocals. Reciprocal means to flip over that fraction. So what I'm really looking at is 2 over root 2. But of course, mathematical taboo, you cannot have radicals in the denominator. So I need to rationalize it. It's called rationalizing. In order to rationalize, I'm going to multiply both the top and the bottom by my radical. So that leaves me with 2 root 2. Now in the bottom over here, when I multiply these two radicals, that gives me root 4. But what's the square root of 4? Hopefully you know it's 2. So now I have 2 root 2 over 2. Lots of 2's. These two 2's in the front, this one and this one, are going to go ahead and cancel out. Same thing on top, same thing on the bottom. So this final answer is going to be the square root of 2. All right, cotangent. So cotangent is the reciprocal of tangent. Now with cotangent, I do not find tangent first. Instead, Tangent is y over x. So for cotangent, I'm going to just do x over y. I'm going to jump straight to flipping over that fraction right out of the gate. So I'm going to look at 3 pi over 4. Searching for 3 pi over 4, here we are. It is negative root 2 over 2 and root 2 over 2. I'm going to go ahead and write it down over here. So negative root 2 over 2 with a root 2 over 2. I'm going to do the same thing that I did with tangent. So I have my x, so negative root 2 over 2, divided by my y, which is root 2 over 2. And of course, we want to multiply by the reciprocal since we are dividing fractions. So negative root 2 over 2 times 2 over root 2. Everything's essentially going to cancel out. If you don't recognize that, you can multiply straight across. That gives me negative 2 root 2 over 2 root 2. And if you'll notice, you have the same thing on top, same thing on the bottom. So that's going to reduce to negative 1. It's the same thing as having like negative 3 over 3. That reduces to negative 1. So even though you have all these radicals there, it's still just the number that you're working with. So don't forget about your regular simplifying skills. Cosecant is the reciprocal of sine. So I'm going to do the same thing that I did when I found secant. I'm going to go ahead and find sine first. And then I'm going to take that fraction and flip it over. So let's see where that takes us. 2 pi over 3. 2 pi over 3 is over here. Cosecant is the reciprocal of sine. Sine is my y coordinate, which is root 3 over 2. So root 3 over 2. Now, that is not my final answer because the question didn't ask for sine. It asked for cosecant. So I'm going to take this fraction and flip it over. So that becomes 2 over root 3. But of course, you can't have radicals in the denominator. So I'm going to multiply by that same radical. That leaves me with 2 root 3 over, this becomes square root of 9, which is 3. So final answer for letter F is 2 root 3 over 3. So big picture, when you're finding the exact values on the unit circle, just remember cosine is x, sine is y, tangent is y over x. And then for your reciprocal functions, secant is the reciprocal of cosine, cotangent's the reciprocal of tangent, and cosecant is the reciprocal of sine. All right, on to topic 2, fundamental Pythagorean identity. So I'm giving you one of your trig functions. So cosine is 12/13, and I tell you that our angle is between 3 pi over 2 and 2 pi. Now, both of those pieces of information are super important. I always like to start with this piece of information first. That tells us what quadrant I'm going to draw my triangle in. So your angles on the x and the y axes are 0, pi over 2, pi, 3 pi over 2. I'm going to go all the way around. I'm back at 2 pi. Well, this tells me that my angle is between 3 pi over 2 and 2 pi. So I'm going to go ahead and draw my triangle in this quadrant over here because it tells me to. I'm going to go ahead and erase my angle measures because I drew this pretty small and I do still need to be able to do the sides of my triangle. So here's my theta. Cosine is adjacent over hypotenuse. So if you don't recognize that, make sure you can spell SOHCAHTOA because that tells us which trig functions are which ratios. So cosine is adjacent over hypotenuse. So when I look at my triangle, my adjacent side is going to be 12. My hypotenuse is going to be 13. I can use the Pythagorean theorem to find my third side. That's a squared plus b squared equals c squared. So I have 12 squared plus b squared equals 13 squared. Continue to solve for b. I get b equals plus or minus, because eventually I'm going to take the square root, plus or minus 5. Now, it's important to note that it could be positive 5 or negative 5. And the way that you tell is based off of the quadrant that you're in. So since I'm in that third quadrant, this side right here is going down. So that means I'm going to use a negative 5. And now that I have all three sides of the triangle, I can go ahead and find my other trig functions. I like to write out all 6 of them, even though it tells me to find 5. I like to write down all 6 of them. I start with sine, cosine, and tangent first. So sine is opposite over hypotenuse, so that's negative 5/12. Cosine was given to me. That was 12/13. Not 5/12. What am I doing? That's 5/13 because I need my hypotenuse. Sorry about that. And then tangent is opposite over adjacent, so that's negative 5/12. And now that I have those 3, I can find the reciprocal ones fairly easy. So the reciprocal of sine is cosecant. And if sine is negative 5/13, that means cosecant is negative 13/5. Reciprocal of cosine is secant. And if cosine's 12/13, that means secant is 13/12. And the reciprocal of tangent is cotangent. And if tangent's negative 5/12, so that means cotangent is negative 12/5. And voila, you have answered number 5. Number 6 is the same. I'm not actually going to do all of number 6 because it is quite repetitive, but I will tell you where that triangle is. So when I draw my triangle, again, it's helpful if you label these angles. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this tells me that my angle is in between pi and 3 pi over 2. So that means I'm going to draw my triangle in the 3rd quadrant. The sine value is negative 48/73. So sine is opposite over hypotenuse. So I'm going to do negative 48 over here, and my hypotenuse is 73. Now, technically, this negative could go to the 48 or the 73, but what you need to remember is that your hypotenuse can never be negative. So that side, that leg, is going to be negative 48. I'm going to use the Pythagorean theorem to solve for that 3rd side. So I have negative 48 squared plus b squared equals 73 squared. And you end up equaling b equals plus or minus 55. After you go through, simplifying all of that. Make sure you put this in parentheses, by the way, when you're squaring a negative. Be careful with that. If I look at the quadrant that I'm in, this right here is a negative horizontal value, so I'm going to use negative 55. And now that you have all 3 sides of the triangle, you can find the other trig functions, just like you did with number 5. All right, next up. Topic 3, graphing sine and cosine equations. So in order to be successful with graphing sine and cosine, you do need to recognize what our original sine and cosine graphs look like. So we use 5 points to be able to graph sine and cosine. Sine will start at the origin, go up to a high, back on your x-axis, which I like to call the midline, down to a low, and then back on your midline or the x-axis. So here's what a sine graph is going to look like. If you had cosine does not start at the origin. It starts on a high, hits your midline, goes down to a low, comes back up to your midline, and then back up to a high. And then this is what one cycle of cosine looks like. So, drew that arrow in the wrong direction. There you go. So if I look at letter A, I have y equals negative 2 sine of x minus 4 plus 3. So a couple things I need to pay attention to is this value right here, this plus 3, tells me that I have a vertical shift of 3. So what I'm going to do is I'm going to change my midline. Normally, this is your midline right here. Normally your midline is the x-axis, but now it's been shifted up 3 units. So I'm going to go up 3 units, and I'm going to draw a line at 3, because that's where my new midline is going to be. My amplitude is this number in front of your trig function. So that means my high is going to be 2 units above that 3, so up at 5. And 2 units below that 3, so at 1. And then other pieces of information I need to pay attention to is the fact that this negative is here. That means I'm going to reflect my graph over my midline. And I also have this piece of information which tells me I am going to move to the right pi over 4 units. So normally your period for this function, which is the length of one cycle, this from here to here, that's one period. Normally that goes from 0 to 2 pi. But I now need to move to the right pi over 4. So normally it's right here. But I'm going to move to the right pi over 4. So now it's right in the middle of 0 and pi over 2. Normally it ends at 2 pi. But I'm going to move to the right pi over 4. So now it's right in the middle of 2 pi and 5 pi over 2. From here, I like to cut this distance in half, and that's where my other point is going to be on my midline. So if I go right in the middle, here's my other point on my midline, and then I'm going to cut in half again. So now I'm looking right here, and since there is a reflection, instead of being up at 5, my other point is going to be down at 1. And then I'm going to cut in half over here, and then that's where it's going to hit the high. And this is my graph for number 7A. All right, let's do letter B. So letter B, I do have this -1, so that means I have a vertical shift down 1 unit, so that's going to move my midline, which is normally the x-axis, but now I'm going to move it down to -1. My amplitude is 3, so from my midline, I'm going to go up 3 and down 3. And what other number do I have? Ooh, I have this 2 right here. So anytime my x is being multiplied by something, what that does is that changes the period. So normally the period is 2 pi. But since I have this number in front of x, my period is going to be 2 pi divided by b. So in this case, it is 2 pi divided by 2, which is just pi. So what that means is normally my period goes from 0 to 2 pi. In this case, since there is no horizontal shift, it's going from 0 to pi. So this is a cosine graph. Cosine starts at your high. So I'm starting up here at my positive amplitude, or higher amplitude, I should say. And my cycle is going to end at pi. So it gets squished. So normally it would end at 2 pi, but because my period has been changed, it now ends at pi. And then from here, I like to cut in half, and that's when I'm at my lower amplitude. I'm going to cut in half again, and that's going to be on my midlines. And this right here is your graph of cosine. All right, let's move on to writing equations. For this one, the very first thing I like to do is identify my midline. So I'm going to go ahead and figure out where is right in the middle of my graph. Here is right in the middle of my graph. And then from here, I can identify cycles of sine and cosine. I'm going to go ahead and find cosine first. I like to find cosine first. That's just my habit. So cosine I find first because I'm just looking from peak to peak. So right here. And then I can find my sine. So cosine, I'm going to write my equation in purple. Sine, I'm going to write my equation in pink. So I need to find a cycle of sine. And the way that I'm finding my cycles is being able to recognize what my graphs look like. So this right here that I'm currently coloring in pink is one cycle of sine. So that means my endpoints are right here and here. Now, in order to write the equation, you need a couple things. Number one, you need to figure out what A is. A is your amplitude. That is the distance from your midline to your high, or your midline to your low. So that distance, in this case, is 1, 2, 3, 4. So A is going to be 4. Next thing we need to do is identify the period. The period is the length of one cycle. So you can find the distance between your pink points, or you can find the distance between the purple points. I'm going to go ahead and find the distance between the purple points because if I look at this first purple point, its x value is 0, and that makes it easier to figure out the distance. So I'm going from 0 to 2 pi, so that means my period is 2 pi. Now, the reason why we find the period is because we need to find b. So let me write the standard form equation for, let's go with, I guess it doesn't matter, but it's y equals a, and then your trig function, could be sine or cosine, b, x minus h, which is your horizontal shift, and then plus k. So I have my a, I found my a was 4. B comes from finding the period. So we've already established that your period is 2 pi over b. If I want to find b, it's going to be 2 pi divided by the period, which in this case is 2 pi divided by 2 pi, which is just 1. So b in this case is 1. Your vertical shift k, that is where your midline is. And as I'm writing the equations, what's going to stay the same regardless of if it's sine or cosine is a, b, and k. So as I'm writing my equation, I'm going to go ahead and start with cosine first. So I'm going to write y equals, it looks like a normal cycle of cosine. It's not reflected at all. So I'm going to do my a, which is 4, cosine. My b was 1, so I don't necessarily need to have this written there. So I'm just going to go straight to x. And then h is my horizontal shift. So normally cosine is on my y-axis, and this one is on my y-axis, so there is no horizontal shift. So I can just do cosine of x, and then plus where my midline is, which in this case is 1. Now let's talk about sine. So once again, your a, b, and k stay the same. But if you'll notice, sine does have a horizontal shift. Normally, it is at the origin right here, but now it's been shifted to the left pi over 2 units. So I'm going to take x minus negative pi over 2, which becomes x plus pi over 2. And there is your equation for 8a. All right, let's do another one. Let's find the midline. So in this case, my midline is down at negative 3. So that's going to be my k when I do write my equation. What else? My amplitude is how high or how low my graph goes from my midline. So my amplitude, which is a, in this case is going to be 2. And I'm going to identify cycles of sine and cosine. I'm going to go with these 2 points for cosine. And then for sine, I'm going to go with this one. And I'm going to look at this cycle of sine. Just to add some variety, this one's going to have a reflection. Okay, so in order to find the period, I can find the distance between my purple points or the distance between my pink points. I'm going to go ahead and use my pink points because if you'll notice, this pink point over here is right on my y-axis, which has an x-coordinate of 0. So the distance between my pink points is just going to be pi. So my period in this case is pi. I do use it to find b. b is 2 pi divided by my period, which in this case is pi. So b is 2. And I'm all set to write the equation. I'm going to go ahead and start with sine first, which was my pink one. So I have y equals my a, which is 2, but normally sine starts at your midline and goes up and does something like this. But if we look at what I have on my graph, this cycle is reflected, so I need to put a negative in front of my 2. So I have negative 2 sine. My b is 2 this time, so I do need that 2 in front of my x. There is no horizontal shift, so I don't have to worry about adding or subtracting anything inside my parentheses. And my midline is down at negative 3. All right, cosine. I have y equals, this is a positive 2 because I went with these peaks over here. There was no reflection. So I have 2 cosine of 2, and there is this horizontal shift to the left, pi over 4 units. So I'm going to do x plus pi over 4. And then my midline, which is at negative 3. By the way, I know it's pi over 4 because I'm going right in between 0 and negative 1/2 pi. So halfway between negative 1/2 is negative 1/4. And there's your equation for letter B. All right, number 9 has everything written out for you. You just have to write the equation. It does ask for a cosine. So I know my amplitude is 3 and it's reflected over the x-axis. So I have y equals negative 3 because I need to deal with that reflection. And then cosine. Next up is the b. So I have 2 pi. So to find b, it is 2 pi divided by my period. Ooh, this looks crazy. So I have 2 pi divided by pi over 2. Let's see, I got a fraction and a fraction. So I'm going to do 2 pi times, I'm going to flip this over because I'm going to multiply by the reciprocal. So times 2 over pi. And that gives me, pi's are going to cancel, that gives me 4. So B is 4. Now, if, the fraction and the fraction freak you out, in your calculator, you can just take 2 divided by 1/2, and you can handle it without the pi's because your pi's are going to cancel anyway, and that's still going to give you 4. So B is 4. And then I'm shifting to the right, so that means I'm going to subtract 3 pi over 4 and shift it down 2. So minus 2 for my vertical shift, which is my k on the outside of my trig function. All right, let's do some word problems. So number 10, you get on your bicycle. It's a beautiful day outside. You're riding your bike. The pedal is 5 inches from the ground at its lowest. When pedaling at a constant rate, it takes 1 second for the pedal to return to the same position. The pedal is 18 inches from the ground at its highest point. So what I like to do is I like to use this graph to identify my lowest point, which was 5 inches, and my highest point. So my highest point is 18 inches from the ground, so I'm going to label that as 18. Now, when I start my cycle, it says it takes me 1 second for the pedal to return to the same position. So my pedal is starting at 5 inches above the ground, and then after 1 second, it's back in the same position at 5 inches above the ground. And what's happening as your pedal is moving around your bicycle, it's going to go up to 18 inches above the ground and then back down again. And if you'll notice, this right here looks like a reflected cosine graph. So I can use that to write my equation. Now, in order to write my equation, I do need to know a few things. I need to know my A, which is my amplitude. I need to know my B and any sort of shifts to be able to write the equation. I'm going to write my standard form up here once again. Usually with these word problems, they end up being cosine graphs. They could be sine graphs as well, but typically they end up being cosine graphs just because you are starting at either your high or your low, not really starting at the midline in these types of situations. Okay, so I need to figure out where my midline is. So I need to find what is halfway in between 18 and 5. So I can find the distance between 18 and 5, which is 13. So that means from here to here is 13. Now your midline is right in the middle of that. So I'm going to cut that in half. So that means this distance is 6.5. And this distance is also 6.5. That 6.5 also represents your amplitude. So now I have my A. And then to be able to figure out exactly where this midline is, because that's going to be your K, I can either take 5 plus 6.5. So I can take my 5, move it up 6.5, or I can take 18 and subtract 6.5 since I want to move it down. But either way, you're going to end up at, what is that? 6.5, 11.5 for your midline. Okay, now the other piece of information I need is to find the B. B is 2 pi divided by the period. The period is the length of one cycle. This right here is the length of one cycle. So your period ends up being 1. So B is 2 pi over 1, so B is just 2 pi. So now I can go ahead and start writing my equation. So I have y equals, this is a reflected cosine graph because normally cosine looks like this, starting at the top. but it is reflected because of the word problem that we're given. So I'm going to make my a negative. So negative 6.5 cosine. B is 2 pi. Now, if I look at my graph, I do not have a horizontal shift since it's right on my x-axis where it's starting. So I have 2 pi x, and then plus my midline, which is 11.5. And now that I have my equation, I want to find the height of the pedal at 2.6 seconds. So all I need to do is take 2.5 and plug it in. So I have 2 pi times, not 2.5, 2.6. Sorry, I misspoke. Plug it in for x. Plus 11.5, and that's going to give you approximately 16.76 inches. Now, a couple things to remember as you're plugging this into the calculator. Double check that your calculator is in radian mode. If it's in degree mode, you're going to get the wrong answer. Also, please be careful when you're plugging it into the calculator. If you'll notice, we got a lot of parentheses here, one right here, one right here, one right here, one right here. So just make sure you're plugging it into your calculator exactly the way that it's written on the paper. That way you don't get an incorrect answer just because you're not paying attention to the details of when you plug it in. All right, one more question. So you're riding a Ferris wheel that has a low point 2 feet above the ground, boop, 2 feet. High point 64 feet above the ground, boop, 64. You start timing at t equals 0 when you get on the Ferris wheel, and it takes 20 seconds to get to the top. So right here is where I'm starting. It takes 20 seconds to get to the top. Whee! Oh, look at that. I only have half of a graph. Okay, so assume the ride moves at a constant rate until you get off the Ferris wheel. I don't want to see half a graph. I want to see a full cycle. So that means if it takes 20 seconds to get to the top, it's going to take another 20 seconds to get back down. So now I can see my full graph. Okay, I'm going to go ahead and find my midline. So the distance between 64 and 2 is 62. So this entire distance, went too far. This entire distance is 62. So if I cut that in half, that makes this 31. And this also 31, which makes my amplitude 31. And then to figure out exactly where my midline is, I can take 2 plus 31, which is 33. All right, what else do I need to find? I need to find B. So B is 2 pi divided by my period, which is a full cycle. Full cycle in this case is going from 0 to 40. So period is 40, which reduces to pi over 20. All right, let's write the equation. So I have y equals negative 31, because again, this is a reflected cosine. Ooh, this one doesn't have a horizontal shift, lucky us. So I have pi over 20 times x plus my midline, which is 33. And I want to find my height after 35 seconds. So I can take 35 and plug it in for x. Once again, please be careful when you're putting this into the calculator. Pay attention as you are going. And after you put it in the calculator, you are at approximately 11.08 feet above the ground. All right, that is the end of this video going over your Chapter 4 review. Good luck on your test.